Hello, I will be explaining how to answer problem number 41 in chapter 2. Um, this one's actually pretty straightforward. It's a little difficult for some because of the algebra, but once you identify the variables, it's actually kind of easy. So let's just first start with a diagram. You're going to have a object that's thrown up in the air, and it's going to obviously come back down. Now, if it was thrown perfectly vertical, obviously it would be coming down the same line. I'm just acting as though it moves to the right to make it easier to draw. And I'm going to say that going up is positive. Okay. None of the variables are given values. They just want you to prove something mathematically. So you're told to show that when you have the initial height, so initial y, you could just say 0 for the reference. And when you have the final y, it's returning back to the initial position. So that's also going to be 0 because there's no change in the height if it returns back to the same location. Um, the velocity going up, okay, is your v y initial, and we just know it's going up. And when the object's falling back down, we know that v y at the end, oops, I didn't want to write equals, is just going to go down. We know that if it's falling near the surface of the Earth, that the acceleration is going to equal a negative g, because remember g is just the magnitude of 9.8. So if you're going to give it the direction, it's going to be a negative g, because I'm saying that um, going up is positive, which means going down is going to be negative. Okay. So with these values, you need to prove, they want you to show that the velocity initially is going to equal, oh, actually I'm blanking now, I think they don't say velocity, I think they say speed. But they either ask you to say that the velocity initial is equal to the negative of the final velocity, or they tell you speed. I'm going to double check that real quick. 41. Say speed. So basically, they want to know that the velocities are equal without the direction. So if we prove that the magnitude of these numbers are the same, it doesn't matter if they're negative or not because you're trying to prove that the speed is the same. So we want to lead to this. Okay, so mathematically we have to use an equation that will yield that answer. Okay, um, we aren't given a time, so we're not going to use an equation with time, which means you only have the third option. So we're going to have v y final squared equals v y initial squared plus 2. And we're going to go ahead and just write a in this case, but it's a, I'm sorry, when I wrote over here a, it should technically be ay because it's talking about the acceleration in the y direction. So write 2 a y, and then you have y minus y initial. Okay? Now, we don't really need to isolate anything because we're just trying to prove mathematically that these will equal. What we really need to do is we need to cancel out y initial and y because those are both 0. And if they're 0, then we know that you're going to have 0 minus 0, okay? Which is going to multiply by ay, which is going to give you a 0, and which is going to multiply by 2, which gives you 0. So that whole right side just cancels out. If all that cancels out, you get vy squared equals vy initial squared. You take the square root of both sides, you get vy equals vy initial, where one of them has to be negative relative to the other. So you have plus or minus and negative, okay? Or sorry, a plus or minus for both of those. Okay, so you're proving that they have to equal. Uh, Mathematically, we know that in this case, if it returns back, we have to have one be negative. Doesn't matter which one. Okay, basically, you could write it like this: plus or minus, or plus or minus. But you know that whichever one is positive, the other one has to be negative. It has to be opposite. But that's all that is. That's your answer. Okay, you don't have to write the plus or minus Vy equals plus or minus Vy initial because they just want to know that the speeds will equal. So the direction has no place in the speed. But mathematically, you should identify that if one of those is a positive value, the other one needs to be a negative value.